Okay, so since we're dealing with ands and ors, we ought to have DeMorgans, right? Ands and ors and nots. We do have DeMorgans for this. So DeMorgans tells us that if we and two things together, and then we negate that and, we get not P or not Q, right? So if we get and the quantity P and, not the quantity P and Q, that's equal to not P or not Q. But remember that for all, xp of x is actually equal to, like, let's say if x's come from 0 and 1, that's P of 0 and P of 1. So if x is a proposition, then this is actually what these are actually equal. For all xp of x actually equals P of 0 and P of 1. So not the quantity for all xp of x is the same as knotting this, right? And then I can use regular DeMorgans with that. Regular DeMorgans says that that's equal to not P of 0 or not P of 1, right? But we actually have a quantifier that's equal to ors for over the entire input space. So this thing that's getting or together is not P of x, and there exists because I have an or. So that there exists a shorthand for or between all of the things that come after it. And since this or is between some not p's, then it's got to be there exists x, not P of x. So we have just done a proof by example of DeMorgans between quantifiers. So I say proof by example because this doesn't prove everything, right? I've only proved it for domains where the x is a proposition. We're going to do later some proofs that are how you could prove this forever, but I'm just going to tell you that it's always true. So if I negate a for all, it's the same as changing the for all into a there exists and negating the inside. So what we've just proven, or we've just shown, demonstrated, not actually proven, is that we can move the knots, but when we do, they flip the quantifier. And it's exactly like DeMorgans for our ands and ors. We can move our knots around, but they flip the variables and they flip the operators. So if I move a knot across a quantifier, by the way, then none of the knots can't jump. When they go through something. When they do, they flip it. Okay? So if I'm going to move this knot over here, I'm going to flip this quantifier to a there exists. And they don't disappear. Knots never disappear. So I can cancel them out with two of them, but they don't disappear. So if you are trying to get rid of knots, remember that you can't just get rid of them. They have to find each other and cancel each other out, like matter and antimatter. Okay, so likewise, I could do the same thing. I could negate both sides of this, right? And then I have another true statement. By the way, these are logically equivalent. So not for all x. So that's for all x, P of x. This is like our secret life of gates, right? It's like secretly a for all is the opposite of a there exists with the insides negated. So what I mean by insides is the statement that follows, the predicate that follows the quantifier and its variable. Okay, so this not applies to the entire statement because the there exists applies to the entire statement. So as I said before, the scope of the quantifier is until I have another one. So, or until I have an operator and then another quantifier. So that is DeMorgans for quantifiers. If I negate a statement that is quantified, I have to flip the quantifier and flip the value of the predicate inside. So that's actually why we had that there exists, a person that doesn't drive a Porsche is the same as not everybody drives a Porsche. So let's go back to that. So we had there exists x not p of x. But if we want to move the not to the outside, then we have to flip the quantifier. So this first one was, there's someone who does not drive a Porsche, right? And the second one is, not everyone drives a Porsche. The second one is easier for us to say in English, because this is easy to say in English, right? And there's no knots in there. Everyone drives a Porsche is easy to say, and it's really easy to put a not in front of that, right? So let's say I give you this statement. I would like you to distribute the not with DeMorgans. Try that on your paper. No, that's just, now we're on a new problem. Sorry. So the question is, are there normally parentheses around the q of x and the p of x and q of x? No. As I've been saying, please don't write any extra parentheses you don't need. So the there exists x applies until, because we don't have any other quantifiers, so it applies on the whole statement. It's just like when you write a program and you say int x, and I can use x forever until I go to another scope. Okay? So doing a there exists x on the paper is very much like saying x equals 1 in a program. It's like picking out a value for x that will make your statement true. It's just that we don't have to specify which one it is. We're just saying that there is one. We don't know which one it is. It's like somebody in this room did something bad. I'm not going to say who it is. Okay, that's what there exists x is for. Okay, so I want you to check with your neighbor about whether they got the same thing when they distributed the not. And use DeMorgans on this. Okay, so we're just going to try to make an equivalent statement that has a not first. So while you're working on that, I'll write the answer to the other one, which I hope everybody got. Okay, I'll give you a hint. The easiest thing to do here is actually to go ahead and put your not outside. And then what do? Apply one of the knots to the inside. I can double negate anything I want, anytime I want. All the time. Yes. Because I just put them there, because everything that's a proposition can always be double negated and it's still the same thing. And I wanted to have a not in the front, so if I made a wish for putting a not on the front, the only thing I'm allowed to do is to put two of them. No, that's not the answer, right? Well, I mean, actually that technically is an answer, right? Technically that is a statement that has a not on the front. So that is a great point. So I didn't specify my problem good enough. I only want one on the front, though. So that means I want you to distribute the second one. So try that. Okay, make sure you're checking with your neighbors, see if they got the same thing. I'm going to write what I get here. Don't do any of it in your head. So I distributed one not across the quantifiers, and then I negate the inside. I didn't do anything else yet. I've only distributed the not across the two quantifiers. Yes?
So when you have your not px and q of x and y, that's one piece?
Yes. So the question is the not p of x and q of xy, is that one piece? Yes.
Okay. So it's not like the for all x and there's y and not p of x is a chunk and then
No, this is not a chunk that goes with that. Quantifiers apply. Basically, even if I don't draw them, this is what's always there. That's what I've been saying, is the quantifiers apply to everything after them. Okay, so this is what we have next. So we're going to copy this stuff, copy, copy, copy. All right, then we're going to distribute this not using our propositional DeMorgans law, right? Okay, so we get not p of x or not q of xy. And then we can do double negation, right? And then we're pretty much done. So we get not there exists x for all y, p of x, or not q of xy.